guys are going to be watching this video on polar and rectangular forms of equations, and the goal is that you'll be able to convert between not only polar and rectangular coordinates but their equations as well. So you are taking these notes by hand, so please make sure that you get this down, and let's proceed. Of course, if you need to, pause the video wherever you have to make sure you get everything down. So reviewing from Friday real quick, you should have read the notes and completed the assignment to know how to convert from polar to rectangular. Of course, you're going to use these formulas. R cosine theta is going to be your x value, and then of course r sine theta is going to be your y value. Because remember, when you're given a polar coordinate, you have r and theta. So you would use those to find x as well as y, which make up your rectangular points. To convert between rectangular to polar, you would use these two formulas where r equals x squared plus y squared with the square root. That will give you your value for r. And then of course, to find theta, you would do the equation tangent theta equals y over x, or you can even think of it like theta equals y over x, or the tangent inverse of y over x. Okay, so you can also think of it like that. Either way, whichever one is easiest for you. Okay, so we're going to take a quick moment just to make sure you guys are good with that. We're going to look at two examples right here. I want you guys to pause the video and I want you to work out these problems, and when you're ready, press play to see if you got them right. So hopefully you got these answers. Do realize, guys, that I didn't have to tell you that. Okay, we're going from rectangular to polar here, and for B you're going from polar to rectangular, because right here you should recognize this is an XY point, and for B you should recognize that's an R theta point. Okay, so you should have had R equals the square root of x squared plus y squared, and you should have got the square root of 97. Then you should have done the inverse of tangent y over x to get your angle. But you also have to remember, guys, which is very, very, very important, where those stipulations based off of where the point is. If the point is in the third quadrant, whatever answer you got for theta, you had to add 180 degrees. So theta wasn't 24 degrees, it was actually 204 degrees. Or if you decide to do it in radian, you would technically add pi. 204 degrees is a particular radian, and so when you add 180 to it, you get this. Okay, just make sure that whenever you do tangent, whether you're in degree or radian mode, you are aware of that. So do be very careful that when you do your math that you are in either radian or degree mode. I did mine in degree. And no, you don't have to be back in function mode, because I know we've changed our calculators to polar. You could do this actually when you're in polar form. It's not going to affect it. However, being in radian degree is going to affect that answer. For B, just as simple. You plug in -6 for R and -120 for theta to get 3. And for y, you plug in -6 and -120 in for sine to find y. Of course, I like exact values, so this would be your exact coordinate, rectangular coordinate, or if you decide to do a decimal, you should have got -5.20. So hopefully that wasn't too bad. You guys remembered. This is really what I wanted you guys to get with this video. Was polar equations versus rectangular equations. As you see in this diagram, and you don't have to draw the pictures, maybe even just make a note of the different types of equations. Rectangular equations have x's and y's in them. Polar equations have r's and thetas in it, as you guys can see. In this very first example, x squared plus y squared equals 9. That does form a circle, hence why the polar equation is r equals 3. In this particular example, we have a polar equation that's definitely a little bit more involved, and we have a little bit more of an involved rectangular equation, but in the end it makes a line. And so basically the bulk of this video is going to be practicing going from polar equations to rectangular equations and vice versa. Okay? So to convert from a rectangular equation to a polar one is actually it's actually easier than trying to go the other way. All you do is you replace x with r cosine theta and y with r sine theta, and then you just simplify the problem using algebra and, of course, our identities. No, we are not done with them yet. Okay, so we're going to do this example. I want to do this one with you and probably the next one, and then I want you guys to try one on your own. And if you, whenever you need to, if you need to pause the video, go ahead and do so. All right. So to go about doing this, we are going to follow the steps. It does say that we're going to replace x with r cosine theta and y with r sine theta. We should recognize this is a rectangular equation because it has x's and y's. And so that's exactly what we're going to do. We're going to replace, oops, sorry guys, I'm not using a regular board, so I have to go through this this way, so just bear with me for a second. We are going to replace x with r cosine theta. And we're going to replace y with r sine theta. Okay, and from there we're going to simplify using algebra and our identity. So right here, when you see that squared, that basically means that we are going to FOIL r cosine theta minus 4. So that means we're going to have r cosine theta minus 4 times r cosine theta minus 4. And we're going to do the same thing with r sine theta. We're going to square it, so that's going to be pretty simple. It's just going to be r squared and then sine squared theta. Okay, you're going to square both pieces. Okay, and when we fold that out, we're actually going to end up with an r squared cosine squared minus 8r cosine theta plus 16. Actually, I don't need that parentheses in front. Plus r squared sine squared theta equals 16. You guys follow me so far? Now the trick is that when you're trying to go to polar form, you want to make sure you basically get in the form of r equals everything on the other side. So our goal now is basically to get everything on the other side and get just r by itself. So to do that, I'm going to start by moving over that 8r cosine theta and that's 16. So I'm going to add the 8r cosine theta over, and I'm going to subtract 16 over. So then that leaves me with r squared cosine squared theta plus r squared sine squared theta equals a positive 8r cosine theta, and then my 16s are going to cancel out. Okay? Now I can recognize that, hey, both of my terms have an r squared in common, so I'm going to factor that out. Okay, that's using a little bit of algebra there. And then you should recognize that cosine squared theta plus sine squared theta is one of your identities. Okay, like I said, we're not done with them yet. So basically, that little part goes away, and you're just left with r squared equals 8r cosine theta. Now the last thing I need to do is I need to get rid of that square, and I know some of you guys are going to think, oh, we'll just take the square root, but if you notice, I still have an r on the other side, okay? But since I have an r on the left side and an r on the right side, I actually, instead of taking the square root, I can actually divide both sides by r. And when I do that, I lose a degree on the left side, so it goes from r squared to r, and then on the right side it turns into 8 cosine theta. And that is your rectangular equation for this particular example. I want to make this a little bit bigger because I didn't know exactly how much space it was going to take up, so there you go. So we replaced x with r cosine theta, y with r sine theta. We did our algebraic processes. We used some more algebraic processes to basically get r by itself. Well, technically we did r squared, and then at the very end, because we could only have an r on one side and everything else on the other side, we divided both sides by r. Now let's look at this example. We're going to look at this one together. Similar process, we're going to plug in r sine theta for, sorry, I'm trying to get the same size, r sine theta for y, and then r cosine theta for x. Okay, so then we'll end up squaring it. And when we square, we're going to get r sine theta equals r squared cosine squared theta. Okay, and remember, the goal is when we're going from rectangular to polar, we want to get r by itself and everything else on the other side. So I can do that by basically getting r squared by itself by dividing both sides by cosine squared theta, and then that will equal my r squared. Okay, and I can actually do one more step, and I don't know if you guys could see it, is that I could actually simultaneously have divided r to both sides as well, just leaving me with the sine theta over cosine squared theta equals r. Okay, and yes, you can do that. You can do simultaneous things when you are simplifying a problem using some algebraic processes, as long as you know it makes sense. So you divide both sides by r, then divide both sides by cosine squared theta, and you're just left with sine theta over cosine squared theta equals r. Now I know you cannot leave it like that because it's a little bit complex, so what you can do is you could actually split it up to say sine theta over cosine theta times 1 over cosine theta equals r. And this is just to simplify it using some of our skills from the identity section to see that, okay, well, sine theta over cosine theta is tangent, and 1 over cosine is secant, and that is your equation for r. So really it's nothing but a matter of some algebraic processes to go about going from rectangular to polar equation. So I want you to try this example. Pause the video, and when you're ready to check your answer, press play. Or if you get stuck, press play and then pause it so you can kind of keep going. Hopefully you guys are able to follow along with that. And I was jumping back and forth trying to make sure it actually looked somewhat presentable, but there you go. Plug in r cosine theta, r sine theta for x and y. Square, factor out, simplify. This is one of your double angle identities. And there you go. So that's how you go from rectangular to polar. Okay. Now we're going to go to convert from polar form to rectangular form. We're going to use, when you do that, it's a little bit more involved. It's not as easily seen, but you use basically all three of these different things at different times, not simultaneously, and you go from there. So we'll look at every type of problem. for the first one is theta equals pi over 6. Okay, so if theta equals pi over 6, well then we know that, well, doing a little bit of an inductive reasoning, we can kind of work backwards, okay? So if theta equals pi over 6, then the only other place where we kind of see theta equaling an angle is when you have tangent theta. Uh, if you basically kind of put tangent there and you think to yourself, okay, well, what's the tangent of pi over 6? Well, that's nothing but root 3 over 3. And think about it. When we were solving equations, right? Didn't we didn't we get to this point where we got the trig function by itself with the theta, and then we took the inverse and we basically asked ourselves where on the unit circle does tangent equal square root 3 over 3, and we came out to be pi over 6. Well, then that's kind of what we have to do here. We have to kind of think backwards a little bit. Okay, so if theta equals pi over 6, then that meant that tangent theta had to equal square root 3 over 3. Okay. All right, and so then knowing that, we know that y over x would have to equal exactly that. It would have to equal the square root of 3 over 3. Okay? If you give me a second so I can get the symbols in there. So y over x equals the square root of 3 over 3. Just doing a little bit of substitution on the tangent theta equals y over x. And so then we basically would solve for y, because when we're in rectangular form, it's usually in the form of y equals, like mx plus b, or y equals, a squared, ax squared plus bx plus c. If we particularly have a circle, then it's going to be, x squared plus y squared equals whatever, okay? So if we solve for y, we'll end up getting the square root of 3 over 3 times x, because we will multiply both sides by x. And that would be our equation. That would be our rectangular equation for the polar equation theta equals pi over 6. Also, think about it, guys. Remember the other day when we were graphing the basic ones, when it was like theta equals 60 degrees, it was a straight line. Okay, well, you need a rectangular equation that's going to give you a line, and that's in the form of y equals mx plus b. In this case, our m is the square root of 3 over 3, which is nothing but a decimal. Okay, let's look at the next one together. You have r equals 7. Well, you kind of already know that the graph of what r equals 7 should be a circle, right? So we're basically going to need a circle equation here. So, and like I said, to go from polar form to rectangular is not as simple as it's not as simple as going from rectangular to polar. So you gotta have to think outside the box a little bit. So you know that r equals 7, which also means that r squared equals 49. Okay, stay with me here. Okay, it's like we're working backwards. Okay, just like how before over here, when we knew that theta equals pi over 6, we kind of had to use the fact that, all right, well, tangent theta would equal square root 3 over 3. We would do the inverse to get pi over 6. Same thing here. The only way to get r equals 7 is if it probably came from a r squared equals 49. Hopefully that makes sense. Okay, so then we would use the fact that r squared is nothing but x squared plus y squared, and we will go ahead and plug that in. So x squared, and if you're hearing this random sound, it's Sheba in the background as I'm trying to do this video. X squared plus y squared equals 49. And that would be our equation. That's the equation for a circle. It's always in that format of x squared plus y squared. Okay? I know this might not come as easily, but, just try to do your best just to follow along, okay? This is the last one that I'll do with you before I want you guys to give it a try. Okay, so we have r equals -5 sine theta. Okay, and we're basically gonna work backwards. Okay, we're gonna use the fact that if r equals -5 sine theta, then that means that r squared, let me make that a squared, equals a -5r sine theta. Basically, all I did was just multiply both sides by r, and then using what I know that r squared is nothing but x squared plus y squared. And then using the fact that r sine theta is nothing but y, I've now gotten rid of those rectangular coordinate or equation pieces of r's and thetas, and now I have x's and y's. Okay? And so then what you would want to do is you wouldn't actually want to leave it like that. You would want to get all of your x's and y's to one side. Okay? So you would add 5y to both sides, and it would equal 0. And there's your equation. Okay? So we're basically using the things that we know from rectangular and polar coordinates and these formulas to kind of help us create our rectangular equation. Okay? So I want you guys to give this one a try. Pause the video, and then when you're ready, press play to see how you did. Alright, hopefully you guys multiply both sides by r to get r squared equals 3r cosine theta. Because without it, you wouldn't really be able to go too far, because you wouldn't be able to plug anything in for cosine theta, and you wouldn't be able to plug anything in for r. Okay? And so from here, we will recognize that, hey, you know, r squared is nothing but x squared plus y squared. And then r cosine theta would turn into x. And so then our equation would be x squared minus 3x, because you always group your x's together and your y's together, plus y squared equals 0. And so hopefully you guys got that. You know, it might not come as easily, you know, right now, but the more you practice, the easier it will get for you. Okay? So yeah.